Assalamualaikum and hi everyone. This week we are going to proceed to the next chapter, which is chapter 7, Simple Harmonic Motion and Waves. In this chapter we have 7 subtopics and I'm going to discuss the first subtopic, 7.1, Kinematics of Simple Harmonic Motion. Okay, so here kita ada a few learning outcomes. First is you should be able to explain SHM, which is the short form for Simple Harmonic Motion. Solve problems related to SHM displacement equation. Derive equations. So you need to derive equation for velocity, acceleration, kinetic energy, and also potential energy. Next one, emphasize the relationship between total SHM energy and amplitude. And last one, you apply velocity, acceleration, kinetic energy, and potential energy for SHM. Okay. So remember before this we did in experiment 5 about simple harmonic motion. Okay, so that is the example in real life. What is simple harmonic motion? So basically simple harmonic motion, okay, di mana kita ada pendulum which is attached to a string, and then kita lepaskan at one point, right? So kita lepaskan at this point and then dia akan goes back and forth. Okay, it goes back and forth over a certain period of time. Okay, so this is what we call as periodic motion, ataupun maksud dia motion that repeats itself over and over again after a certain period of time. So dia repeat kan, daripada sini patah balik ke sini and balik lagi ke sini, patah lagi balik ke sini. So this is what we call as periodic motion ataupun simple harmonic motion. Okay, so here, if we see the definition of simple harmonic motion, okay, it is defined as the periodic motion without the loss of energy. Okay, they are without the loss of energy. So in this motion, we have two types of energy yang terlibat. Okay, one is we have kinetic energy. Since dia adalah motion, dia bergerak with some sort of velocity, so dia akan ada what we call as kinetic energy. And then since the object is moving at one point to another point, so kita ada dua point yang berbeza. So when we have two different point, meaning that we have a displacement here. So meaning that we have a potential energy. So ada dua energy yang terlibat lah, kinetic energy and also potential energy. So in simple harmonic motion, there is no loss of energy. No loss of energy under a condition over a period of time. Okay, we know that apabila kita lepaskan pendulum ni kan, after some time dia akan makin slow and then eventually dia akan stop. But within a certain period of time, for example within 10 second lah. So within 10 second dia akan stable. Okay, dia akan stable, still moving. So during that time we call it as simple harmonic motion, di mana energy dia tetap sama, energy dia tidak berubah lah, there is no loss of energy. So that's why kita cakap simple harmonic motion ni there is no loss of energy during this period of time, bukan during the whole time lah, bukan during the whole situasi. Okay, so simple harmonic motion is defined as the periodic motion without the loss of energy, in which the acceleration of a body is directly proportional to its displacement from the equilibrium position. Okay, so here the equilibrium position for this one adalah daripada tengah. So this is the equilibrium position. This is when there is no force acting on the pendulum. So dia adalah at equilibrium, bermaksud displacement dia sama dengan kosong. So ke sini displacement dia adalah at maximum tapi on positive direction. Ke sini displacement dia adalah at maximum but on negative direction sebab dia adalah opposite direction. Okay, so the acceleration is directly proportional to the displacement. Okay, in this topic kita gunakan simbol Y untuk represent displacement. Before this dalam linear motion, okay, in linear motion kita gunakan S, right? And dalam rotational motion and also circular motion kita gunakan angle untuk represent displacement. But here we use simbol Y. And then is directed toward equilibrium position but in opposite direction with displacement. Okay, so apa yang dia mau cakap adalah acceleration ni directly proportional to displacement tetapi opposite direction. But in opposite direction, that's why kita ada negative di sini. Or mathematically we can write it down di mana acceleration is equal to negative omega square times with Y. Okay, negative to indicate the opposite direction. Omega here is the angular frequency ataupun nama lain yang kita gunakan before this, angular velocity, which is always constant. Okay, angular frequency always constant. And then times with the displacement lah. Displacement adalah displacement from equilibrium position. Okay, equilibrium position dia adalah dekat tengah sini ataupun dekat mana-mana lah yang di mana there is no force acting on that object. Okay, so there are a few examples of simple harmonic here. This one simple pendulum yang kita buat before this. This one when we have a frictionless horizontal spring oscillation. Okay, so spring tu kita akan tarik dia with some sort of force. So dia akan move back and forth. So this is simple harmonic motion juga sebab dia akan keeps on repeating itself. And also vertical spring oscillation. Okay, so here we have a few terms that we use to describe simple harmonic motion, di mana semua term ni actually kita pernah guna lah in the previous chapter. Okay, so kita first of all let's look at the equilibrium position. So equilibrium position macam yang Miss cakap, it is a point where the acceleration and force exerted on the body undergoing oscillation is zero. Maksudnya dia at equilibrium di mana kita tidak apply force on the object. So that is the equilibrium position. Okay, dalam gambar ni kita gunakan X, but in our chapter, in our syllabus kita gunakan Y instead of X lah. Okay, and then this one displacement, distance from equilibrium position. Okay, so equilibrium adalah dekat sini apabila kita tidak tarik dia punya spring ataupun kita tidak we didn't extend or compress, which is here. And then when we extend, kita extend at certain point lah from the equilibrium. So equilibrium tadi dekat sini, this is the value for displacement. So again this one should be Y, not X. And then amplitude is defined as maximum magnitude of displacement from the equilibrium position. Okay, maximum maksudnya jarak yang paling jauh yang kita boleh tarik for the simple harmonic motion, either for the pendulum ataupun for the spring. Next one we have period, which is T. It is defined as the time taken for one complete cycle. Okay, one complete cycle. Next one, frequency, which is defined as the number of complete cycle in 1 second. Okay, dalam satu saat tu berapa kali dia boleh goes back and forth, berapa cycle yang dia boleh buat. So that is frequency, di mana formula untuk frequency adalah 1/period. Next one we have angular frequency ataupun angular velocity, di mana kita punya equation adalah 2π/T ataupun 2π times with F, di mana SI unit will always be radian per second. Okay, next one we have what we call as restoring force. Okay, I think I've discussed this term before in chapter 3 if I'm not mistaken. Chapter 3 or 4. Okay, we have learned about restoring force, di mana dia adalah a force that tends to bring a system back toward equilibrium. Okay, sebagai contoh kita ada this mass which is attached to a spring. So apabila kita apply force, okay, initially dia adalah at equilibrium and then kita apply force, which is kita apply force to this side. Okay, kita extend lah the spring. So when apabila kita lepaskan, mass ni, this body, what happens to this is dia akan goes back to its original position. So bermaksud when we apply force of 10 Newton, we have another force what we call as restoring force. Okay, restoring force yang menyebabkan this body to move back to its equilibrium position. Okay, if we apply 10 Newton, the same value of 10 Newton akan di-apply to this body but in opposite direction. Okay, so that's why the value for F, this one there should be a value for F here. Okay, the restoring force is always equal to negative Ky. Y dekat sini adalah the displacement, and then K adalah the spring constant ataupun force constant. Okay, I think in the previous chapter kita gunakan Fs is equal to negative Kx. Benda yang samalah, X adalah displacement, but in this chapter kita gunakan Y. So these are all the terms that we are going to use in this chapter. Okay, next one, let's look at the simple harmonic motion displacement equation. Okay, so this is the displacement equation. So kita ada satu displacement equation yang kita always akan guna. This is what we call as the general displacement equation, di mana Y, which is displacement, is equal to A sin omega t. Okay, so A dekat sini is the amplitude, omega is the angular velocity ataupun angular frequency, and then t is the time. Okay, so since kita punya equation adalah A sin omega t, okay, it is a sine equation. So kalau kita plot the graph will be a sine graph lah, ataupun what we call, nama penuh dia sinusoidal graph. Okay, so it will start at 0. Okay, di mana apabila t sama dengan kosong, angle sama dengan kosong. Okay, apabila t sama dengan kosong, angle sama dengan kosong, y pun sama dengan kosong. So it starts with 0, dan dia akan naik to the maximum value, di mana maximum value ni adalah the amplitude, goes back here and then goes here, and then it will keep on repeat lah. So this is the graph untuk displacement equation, and then equation dia adalah y is equal to A sin omega t. Okay, so under certain condition, kita akan gunakan this one, di mana kita akan ada value for angle. Okay, ataupun kita panggil dia sebagai phase constant. Okay, this one I will explain. Actually, we don't really use this one, but I will explain during the in example yang memerlukan the angle here. But just remember, this is the general equation that we are going to use in this topic. Okay, next one, let's look at the equations of velocity, acceleration, kinetic energy, and potential energy. Okay, so dalam learning outcome kita ada, okay, let's look at the learning outcome again. So learning outcome yang ketiga, you should be able to derive equation of velocity, acceleration, and kinetic energy. So kamu kena tahu macam mana nak derive equation dua ni. Yang paling penting lah dua ni, velocity and acceleration. How can we derive this equation? Okay, so since this one adalah our general equation, and in order to find V, kita kena derive displacement, okay, dy over dt. So when we derive, okay, the equation untuk V daripada y, kita kena differentiate. So how do we differentiate? Differentiate saja macam biasa, d over dt, and then differentiate A sin omega t. So when we differentiate, kita differentiate A in respect to omega, so kita akan dapat A omega, and then kita differentiate sin akan dapat cos, and then the rest you just salin saja, cos omega t. So this is the equation untuk velocity. Okay, so this one lah. So boleh salin dekat dalam nota kamu, since I didn't include this one initially. Okay, always remember that cos omega t will always be equal to plus minus 1 when the velocity is maximum. Okay, when the velocity is maximum, this one akan jadi sama dengan 1. So our formula now will be equal to omega A saja. Okay, this is the formula untuk maximum speed ataupun maximum velocity. And the next one, in order to derive acceleration, kita kena differentiate. Okay, kita kena differentiate the equation untuk velocity. So we differentiate. Okay, let's differentiate A dv over dt. So you differentiate d over dt. V tadi A omega cos omega t. And then you differentiate this one in respect to omega. So omega A omega square. And then differentiate cos, akan dapat negative sign. And then the rest you just tulis saja semula. So akan dapat negative A omega square sin omega t. Okay, so this is the equation untuk acceleration. This is the equation untuk velocity. And these two is also equation untuk acceleration and velocity. But this one is to show the relationship between velocity and displacement. This one, displacement and acceleration. Okay, so kamu kena ingat untuk cari maximum acceleration, sin omega t will always equal to plus minus 1. So then this one is plus minus 1. Okay, acceleration akan dapat A omega square. Okay, maximum acceleration akan dapat A omega square. And then these are the equation untuk kinetic energy and potential energy. And this one is the total energy. Okay, total energy. So nanti kita akan tengok dekat dalam soalan examples how to use all of these formulas that we have in this subtopic. Okay, so I will discuss the examples in the next video. Thank you.